Systems of equations. All right, so a system of equations, this is when you're going to have two equations, okay? And we can solve them by graphing. We're going to look up today is graphing and substitution, okay? So there's three ways to solve them. We're going to look at two of them today, okay? So you're going to have two equations. Normally they're going to be in slope-intercept form, all right, which makes it easy to graph because we've gone over slope-intercept. You guys are really good at graphing that. And we're going to show you how to solve those, okay? So the first method we're going to look at, okay, substitution. We'll look at solving by substitution. So our first method is going to be solving by substitution, okay? So what I'm going to do is we're going to do what we normally do. Put an example down, talk about the steps, and kind of go with it, all right? So example one, our system is going to be y equals negative 4x plus 2 and y equals 6x minus 8. Okay, so these are two equations. We're going to solve these by using substitution. All right. So step one, we'll write those over here. Step one, we're going to look at both equations. Okay, and we're going to make sure at least one equation is solved for a variable. Okay, we want to make sure at least one of these is solved for a variable. And what I mean by that is do I have y by itself? Do I have x by itself? Okay, so if you want to in parentheses, you can put it can be x equals something or y equals something. Okay, you have to have x or y by itself on one side. All right, do we have that here? Well, yes, I can have both of them. I have y equals here and a y equals here. Okay, so the first step's taken care of in this example. All right, so step two, we're going to substitute one equation into the other. And solve. Okay, so what I mean by that, by substitute one equation into the other, we're going to use substitution. So if I said y equals 3x plus 4, x equals 9, what are you going to do? Well, you're going to substitute 9 in for x. I told you that's what it was, right? Okay, so for this example, what I'm going to do is, let's take this first one, y equals negative 4x plus 2, okay? And what does y equal? Well, y, let's say if I use this equation, here's what y is going to equal here. Okay, I'm going to take this and I'm going to substitute it in for y. Okay, so we're going to have 6x minus 8 equals negative 4x plus 2. All we did was we substituted. This is y. Okay, I took it and I substituted in for y. And now we're going to solve. Well, what do you mean by solve? Well, I mean, we're going to solve for the variable. We have a multi-step equation now, okay? We have variables on both sides. So I'm going to solve for x here, all right? So let's solve for x. So what we're going to do first, again, I'm going to draw a little line here so we can separate it. We're going to get the x on the same side. So I'm going to move the x to the left. I'm a lefty, I like it on the left, I'm sorry. The opposite of negative 4x is positive 4x. We're going to do to one side. You do to the other. Great job. All right. 6x and 4x gives me 10x. Bring down the odds left. Minus 8 equals, one thing left over here is positive 2. Now we have a two-step equation. We're good at these. We're going to roll with it. Let's add 8 to both sides. What you do to one side, you do to the other. All that's left over here is 10x equals 10. Divide by 10. What we do to one side, we're going to do to the other. X equals 1. Okay. Are we done? No. We have two parts. We have an x and a y. Okay. I've solved for x. Well, now it's time to solve for y. Okay. So once we solve for x, the last portion here of our notes, all right, is step 3. Okay, so for this example, we're going to sub in x into either one of these equations. Okay, we're going to substitute solution. Move out the way, Reed. Substitute solution from step 2 into one of the two equations. Now, why doesn't it matter which equation I use? Okay, the reason it doesn't matter is because both of these are a system of equations, which means that they're both, the solution will be the same for both of them. Okay, so I'm going to take this one, and let's say we'll just use this bottom one since it's already here, and I'm going to sub it in. So y equals 6. Take my 1, I'm going to sub it in. I'll change my color here so we can see that better. Sub in my 1 there. All right, minus 8. And now we're going to solve. Okay, and this will give us our y. 6 times 1 is 6, minus 8, and 6 minus 8, negative 2. Y equals negative 2. Okay, so for this example, okay, your final solution, your solution for both of these will be 1 comma negative 2. And that will be your answer for that system of equations. All right, so what does that mean? Well, that means if I were to take these two graphs, okay, or these two equations, and if I were to graph them, all right, that means that they would intersect at 1, negative 2. All right, that's what would happen there. Okay, I'll give you guys a second. We'll do one more together. All right, then we'll move on to the next part. All right, so we're going to do example 2. And again, we're solving a system of equations by substitution. Let's say I have 2x plus y equals 3, and y equals 2x plus 1. So if I look at my last page, okay, step 1 tells me make sure at least one of the equations solve for a variable. In this example, we have both equations. If I look at my next example, all I have is I have one equation that is solved for a variable. Okay, I have y equals right here. All right. Now it doesn't mean I have to take this other one and I have to solve it for x or y. I don't have to. Okay. So what we're going to do is we're going to take my 2x plus y equals 3. And I'm going to take this equation and I'm going to take this part, I'm going to substitute it. What am I going to substitute it for? I'm going to substitute it for y because that's what y equals. Okay, so I have 2x plus, my parentheses to show substitution, and I'm substituting 2x plus 1 equals 3. All right, I have nothing outside of here. I'm doing the distributive property, so I can just drop the parentheses if I need to. Okay, and that eraser is massive, and I don't know why. So now let's combine like terms. We're just solving this equation now, just like we would if I said, hey, give you this, put it on a piece of paper, and say, hey, solve. Okay, but a lot of times what happens is some people get stuck because they're thinking system of equations. This is something different. This is something new. Well, I mean, it's new, yes, but it's still a system of equations regardless of what we're doing. All right. So let's solve this. Okay. So I'm going to combine my like terms. 2x plus 2x gives me 4x. Cancel that, bring down what's left. And now we have a two-step. So we're going to subtract 1 from both sides. All that's left is 4x equals 3 minus 1 is 2. We're going to divide by 4. Divide by 4. X equals, I'll reduce this 1/2. Okay. So I have my x coordinate now. All right. So again, if we go back and we look and see, it says substitute one equation to the other. We've done it. Step 3, we're going to substitute our solution from step 2 into one of the equations. So we can choose either one of these we want to. Now, if we're thinking logically, okay, I have x, I need to solve for y now. Well, y is by itself in this equation. I'm probably going to use this one because if I use the other one, it's just going to be more work I have to do. Are you wrong if you use the other one? No, you're not wrong at all. Okay, so we can use either one of these, but I'm going to use this bottom one, y equals 2x plus 1, because it's already solved for y. I don't have to do anything else. Okay, so I'll take my x value, sub it in, all right, and then we just solve. 2 times 1/2 is 1, and 1 plus 1 is 2. So y equals 2. So that would mean that my solution for this particular problem is 1/2, comma 2. So if I was to graph this, they would intersect at 1/2, 2.